हो, नमस्कार. ऐकू येतोय माझा आवाज?
Oh, welcome all the members. Good evening.
बोरा सर जॉईन होत आहेत.
ओके. सर 5 मिनिटं थांबूयात ना अजून आपण.
बाकीचं
Good evening everyone. Good evening all dignitaries and directors of PMA, Mr. Pradeep Chitle sir and Dr. Nitin Zundarkar sir and all other dignitaries. Today we are hosting one more webinar which is an initiative of PMA COE, that is Business Excellence Group. Today's seminar is on technological changes in Indian automotive manufacturing industry. This seminar is in with association with PDPCA, that is Pune Divisional Productivity Council and Indian Institution of Industrial Engineering. On behalf of PMA COE Business Excellence, I welcome everyone, all the participants who are here to listen to great information which will be shared by our spokesperson. To start with, I would like to share few guidelines for everyone's that please keep your audio mute so that there won't be any disturbance during the session altogether. If you have any queries, anything you would like to know about more about the session, please put it into the
And on behalf of PMA, I take this opportunity to welcome all the members, all the dignitaries also for today's this full of knowledge webinar. Pune Management Association is a center of excellence in the domain of management that empowers the individuals and enterprises to excel in their own path. Pune is engaged in and distribution of knowledge. It is also carrying out activity of enhancement of the skills, and the main focus is on application of best practices in the industries. So PMA is focusing on providing a wide range of services to improve the standards of management practices in India. PMA organizes conferences, seminars, relevant programs, lectures, discussion meetings, and not limited to this, rather PMA is running 14 different verticals in the form of center of excellence. For example, like if I name you, academics, business excellence, civic affairs, career guidance, finance, then skill development, IT, HR, innovation and emerging technology, quality, sales. So all these are the different verticals which are connected and which are very much vibrant under the guidance of PMA's management committee. There are many collaborations that are nowadays which have taken place for the training activity as well as for technical management activities in the industry. This is all about PMA. I welcome all of you this webinar. Now I will take the opportunity even to introduce because today's our event is in association with PDPC and Triple I. So this Indian Institute of Industrial Engineering, Triple I will take this opportunity on behalf of Mr. Mohan Kulkarni, who is presently chairing this Pune chapter. He is chairman of the Pune chapter, and the current their council body honorary secretary is Mr. R.K. Patel. So this Triple I Pune chapter, it was founded in 1970, and it has well equipped their own office on Pune Satar Road. They are basically the Pune chapter is one of the vibrant chapter among over 30 chapters all over India, and they are providing guidance on non-commercial basis to and even for the students. So on foundation day of this Triple I, that is on 27th of January They conduct presentation of awards for those who have taken participation in this contest. They are also involved in organizing and conducting one-day training programs on different management techniques like SCM and most. Even lean manufacturing, that is also another area. They are offering their training programs. They are also actively involved in opening student chapters. One of them is established in Vishwakarma Institute of Technology. Over 400 students from Pune, they are appearing for the graduate examination in industrial engineering, and the guidance for different subjects and projects to the students who are appearing for the graduate examination. This industrial engineering Pune chapter, they are very much extending their all help in all these areas. So on behalf of them also, I welcome all of you. So on behalf of PMA, PDPC as well as Triple I welcome everyone for this today's event. Madam, over to you. Thank you.
Thank you, Dr. Nitin, and welcome, Mr. Mohan. Pleasure to have you on this forum. And our associate partner, that is PDPC, Dr. Nitin, I guess Mr. Anil Kekar is yet to join. So, would you,
Okay,
Mr.
good evening.
Wadikar, can you please brief about the PDPC? We have Mr. Pramod Wadikar also.
Are you able to hear me?
Yes, sir. Yes.
Yeah. Okay, good evening to all of you. And I will take not much time because all of us is a very old organization. It started in 1959. I think most of us were not even born who are here when the PDPC started. We are local counterpart of National Productivity Council, which comes under Department of Industries, Government of India. PDPC, that is Pune Divisional Productivity Council, is one of the most vibrant productivity council in India. Okay, it is all over. In last 60 and odd years, we've been offering consultancy and training mainly to manufacturing organizations. We have provided training to more than 35,000 employees at all levels, and we are continuously engaged in those activities. We are also planning to have a few programs in association with organizations like Pune Management Association. We have offered consultancy to more than 600 organizations, and mainly in the area of time and motion study, optimum manning, time standards, methods improvement, productivity improvement, staff studies, logistics and supply chain, and others, to all sectors, that is small and medium sector to the large sector. We are also operating all over India. Today itself, I have an inquiry from Himachal Pradesh. Couple of years back, we did an assignment in Punjab. Last year, we had an inquiry from Coimbatore, etc., etc. So it's one of the few productivity council, local productivity council, which is enjoying trust and confidence of industries all over the country. Okay, I will not take much time. Like all of you, I am also eager to listen to our speaker. Thank you so much for the time.
Thank you, Mr. Pramod Wadikarji. It was great to know about your PDPC. Before we actually start, welcome everyone again, because we have a good number, and I'm eager to hear about our program. So before we start, I take a pleasure to introduce about our speaker in a brief. Today on panel we have Dr. Kamal Bora. We are actually very much thankful for him to join, because it's actually a very last moment. He has agreed to help us because our earlier spokesperson, Mr. Sharad Goswami, he had some emergency at home, so he won't be able to join. But Dr. Kamal Bora has accepted our invite and has agreed to speak about this session. So it's actually like we don't have any words to express our gratitude towards Dr. Bora. To introduce in a brief, Dr. Kamal Vora is a PhD holder from IIT Mumbai. He is a visionary leader with impact on research, validation, and skill development areas. Uh, Global teacher on automotive engineering, engine and emission control, and electric mobility. He has a vast experience over 19 years in industry and 18 years in academia. He is specialized in education, training, L&D, R&D, KM, HR, and admin. He's also a team leader and motivator with high energy level of ESTJ. Dr. Vora is also strong believer of quantifiable, measurable targets. He has worked as a senior divisional director of ARAI and also head ARAI Academy, chairman Automobile Skill Development Council on electric vehicles. He is also a chairman of SAE India. He is also professor emeritus of College of Engineering, Pune. Uh, Last but not the least, he has trained at Ford Motors USA, General Motors USA, US EPA Corning USA, 3M USA, Emitech Germany, Mahindra and Mahindra, EU India, Partnership, IIT Bombay and Delhi. He is also trained at Premier Automobiles Mumbai, Best in Mumbai, and CC Shroff Research Institute of Mumbai.
Thank you very much.
On behalf of PMA, PDPC, and III, I express my deep gratitude to you for last moment you added to help us. Thank you again, and over to you, sir.
Thank you. Thank you, Arshada, and thank you, Mr. Tupe, and thank you all the office bearers and the guests. Yes, it was told to me at around 6 o'clock that I had to give this presentation, so I did my best to prepare the presentation. I also went through all the questions which Mr. Pradeep Tupe had sent it to me, which you had sent it to them in advance. And I tried to do as much justice as possible to put answers related to those questions. But probably all the answers I was not able to do it because when he called me, I was in Talegaon and I just reached home at 7:45. Anyway, so let's start the presentation. I'm sure you would find it also will get affected. So all this, everyone has to work hand in hand, and that's why CR and ECMA also work hand in hand. Green mobility is something which is very, very important, and everyone has understood the importance of sustainability. And hence, everyone is moving towards that. You, me, everyone has to work on how do we use green mobility, how do we use green technology everywhere. Similarly, innovation, research and development, startup are the new areas which our government is moving. For all these things, we also require a very good skill development, which would be a part of the ecosystem. Okay. So what is changing? What is the change in this so many years we have been producing automobile? We have been producing automobile from 1940 onwards, and the worldwide we have been producing automobile from 110 years. So the economy is growing, consumerism is also increased, and there is a digital exposure. So whether it is on laptop, whether it is on mobile, them. और जब बाप को अपनी बेटी की शादी करनी रहती है तो 6 महीने पहले 1 साल पहले स्कूटर बुक करता है दामाद को दहेज में देने के लिए. That was the monopoly in those days. Now it is customer oriented market, it is the buyer's market. So the buyer decides which vehicle he would buy, and accordingly the seller will get the market. So because of all these changes in the Asian countries, mobility has gone through a transformation. We'll see what is this transformation. So up till now, we have been using shared mobility like buses, auto rickshaws, trains, and taxi. But now there is a new way of emergence of mobility. You can see if I want to book a bus, I will go to Red Bus. And if I want a car on rent, then I'll just click a button on Ola, Uber, and I would get the vehicle. So digitization has resulted in the emergence of a new shared mobility, and we can share the vehicles, right? In Ola, three people can go from different areas and they can go together, or three people from the same family can travel in Ola. However, there are key challenges for mobility. These are like high expenditure due to improved standard of living. When the standard of living increases, then if the neighbor buys a car, then I also feel like buying a car, or my wife also feel like buying a car. There is also very high congestion because more and more people are shifting to cities. Today, 40% of our population are in city, and it is expected by 2030, 50% of the population would be in the city. And hence, they will buy more and more vehicle, and hence the human population as well as the vehicle population would be high in the city. And that is why government is coming out with micro cities or many smart cities. For example, between Gujarat and Maharashtra on the highway, they are coming out with around lot of smart cities, maybe around 100 smart cities. So this will ease out the congestion. Then we have high pollution because whatever you do, whether you impose BS4 norms or skip BS5 and impose BS6 norms, overall pollution is not going to go down because we have around 250 million vehicles which are still running on Indian roads. माने दादा भी यूज करता है, बेटा भी यूज करता है, पोता भी यूज करता है. गाड़ी का रजिस्ट्रेशन नंबर वही रहता है, पार्ट्स शायद थोड़े चेंज हो जाते हैं. So the life of a vehicle is higher than the life of a human being, and we are working also on that. There are scrappage policies and other policies are coming up, and after 15 years you have to re-register your vehicle. Then comes the oil import bill. We are spending a lot of money in buying crude petroleum from abroad, and then that is the reason why gasoline and diesel are becoming costlier, and hence we need to work on various alternative sources. And then, from safety point of view, there are high road accidents and death, and hence we need to make our vehicle more safer. So we need to find solution to these challenges, and who would find this? You and me, and automotive industry, and institutions who are doing research like ARAI, ICAT, GRC, and others. So basically, we are talking about last mile connectivity. It is easy to develop bus road transit, BRT. It is easy to develop metros, and there are now so many facilities through which the mobility gets enhanced. Mobility has become one of the necessity. It is no more a luxury. So there has to be an integrated mobility solution for the last mile connectivity. So probably if I want to go from my office to my home to office and back, then from my home to metro, and then from metro to office, there has to be some connectivity. So there could be some cycles there could be some electric two-wheelers there, and people can use that. And that's how we need to look into the last mile connect. So Mahindra has come out with a last mile connectivity company also who would work on this. Okay, fine. So with this, I would tell you that there has to be a disruption in automotive technology in the global context. We are talking about electric vehicle, we are talking about shared mobility, but we also have to talk about connected vehicle and autonomous vehicle. When I say connected vehicle, when you cross your toll, then you don't have to wait, you don't have to pay, it gets deducted from your FASTag. That is just one way of connectivity. I will be talking about different ways of connectivity in subsequent slides. Then we autonomous, connected, electric, and shared mobility. But in the Indian context or in the Asian context, we have tweaked this acronym. And A now stands for affordable solution, C stands for connected and shared mobility, E stands for environmental friendly and energy security, and S stands for safer mobility. So what was autonomous, connected, electric, and shared mobility in US and European context? This in Indian or Asian context is affordable, connected, and shared, eco-friendly, and safe mobility. Affordability is something which is very, very important in India, and at the same time, we feel that safety is also very important in India. Eco-friendly includes electric vehicle and alternate fuels, and connected would include connected and shared vehicle. So with this background, I would now talk about the technology trend, and then I will narrow down to electric vehicle. So safety is the most prime concern, and hence we need to work on various active and passive safety. Active safety is something which is inherent in the car, like we use a horn, we use a brake, or we have a windshield. And active passive safety is something which is useful when the accident it takes place, about to take place, or it has taken place. So use of seat belts, use of airbags, these are all part of passive safety. So you can see seat belts are very important, not only in the front but also in the rear. It is important to wear the seat belt. Head restraints are very important. Head restraint is not a head rest, but when an accident takes place, when a crash takes place, the head moves forward and then there is a whiplash, it moves backward. At that time, this head restraint does not allow you to move backward. Then we have airbags, and airbags are external, airbags are internal, airbags are on the top, on the steering wheel, on the side, everywhere, also on the knees. So active and passive safety technologies are here, and through automotive industry standards, we have been implementing all these standards which are required to make the vehicle, passenger, and the pedestrian safer. Then comes the intelligent vehicle technology. I already talked about the connected vehicle and paying of the toll tax, but we are also talking about vehicle to vehicle communication. That means if one vehicle can understand the second vehicle and is able to communicate between two vehicles, the accidents will never take place. I would come to know that some vehicle is near me, I would slow down or he will slow down. And when the vehicle comes very near to each other, automatically the brake would be applied and the accident will not take place. So V2V, and there are many others V which we will talk about. So for this, we require a series of cameras, series of sensors, and automotive sensor and electronics is thus playing a very important role. Similarly, we need to find out the range, whether it is radar, LiDAR, or LiDAR, or sonar. There are various technology by which we can find out about the other vehicle, we can find out the range. And these connected vehicles are basically working on dedicated short range communication, DSRC. And this finally leads to an intelligent transport system, right? So the main motivation is to use an intelligent transport system. And in all smart cities, when they are developed, right from beginning, the intelligent transport system is advocated. So one is vehicle to vehicle communication. And for this, we need to work on various diagnostics and prognostic, and hence data mining, diagnostics of those data, data analytics are very, very important. And hence courses related to data analytics have become famous. As far as data science is concerned, we need a powerful hardware, a powerful programming tool, and efficient algorithm to capture the data, to understand the data, and to analyze the data, and to use those data for betterment of the mobility. The next step is artificial intelligence. So we have to use AI, ML to ensure that our vehicle becomes more intelligent. And vehicle, for example, would be able to find out where are we going and what is the route. And then something like Alexa can tell you that whether you would like to have dinner, then I can suggest, or you have couple of birthdays, your friends are celebrating their birthdays, then I can suggest you that you should go to this restaurant and have dinner there. So artificial intelligence, AI, is also as a machine intelligence, and it is demonstrated by machines that this machine can work and think like humans. So through artificial intelligence, we have to teach machine how to reason, how to solve problems, how to generate knowledge, how to do planning. So artificial intelligence AI is also as a machine intelligence, and it is demonstrated by machines. So through artificial intelligence, we have to teach machine how to reason, how to solve problems, how to generate knowledge, how to learn. So this machine also requires training, speech recognition, perception, motion, and manipulation. All these together will make the vehicle intelligent. So it will make the vehicle intelligent. For this, we have to create expert system, we have to implement human intelligence in machine and pattern recognition, face recognition, computer vision system, natural language understanding. These are the areas which we have to work on. So many universities have started BTech course in artificial intelligence, and also now master's course in artificial intelligence are also being planned. So for artificial intelligence and machine learning, you need to understand the systems, you need to understand the machine learning, and you need to understand its platform, frameworks, and library. So a lot of work is required, and relearning or reskilling is something very important for all of us. to understand that we need to reskill ourselves in this area, otherwise we will be left out. So sensors, lidar, radar, GPS, IMU, these are the new things which are getting implemented in vehicles to make it more connected and also probably more autonomous or driver assisted. So that's what I go. Next step is autonomous vehicle. Yes, autonomous vehicles were tried in 1920s, but the true autonomous vehicle came in 1977, and many countries have given permission to do trial on autonomous vehicle at a certain level at certain routes. So there may be an autonomous vehicle from Paris bus stand to Paris airport, or there may be some autonomous vehicle route at London. So in future, you won't be surprised if you find an autonomous vehicle route between the domestic airport in Bombay and the international airport in Bombay, because they have a special route. So we need to find out special routes and limited routes through which we can start this trial. However, Indian government is still not given permission to do trial on autonomous vehicle on road. But a lot of research is being done on autonomous at ARAI, at ICAT, at IIT Hyderabad, at IIT Chennai, and people are working in these areas. I remember when I was at ARI, I had developed an autonomous tractor. We have a patent for that. And in USA, it is very common to run 10 to 20 tractors on a farm where you don't find any driver. Everything is controlled from a single room. Okay, but for that we require a very big farm. So autonomous are defined by SAE in various level 0 to level 1, 2, 3, 4, 5. So level 0 is what we drive our manual vehicle as on today, where hands-on and eyes-on are required. And when we shift to our automatic transmission, and when there is a longitudinal or transverse guide, we call it as level 1. And when we are able to temporarily remove our hands and eyes. For example, in an automatic transmission, you can set the vehicle will run at 50 kilometers per hour continuously, and you can do that. You don't have to put your feet on the accelerator or any pedal. So that is level 2. So up to level 2, vehicles are available in India, but level 3, level 4 are being developed. But abroad, level 3, level 4 vehicles are available. As I told you, in Dubai, we have driverless taxis available now. So you call a taxi with a click on your mobile, and you will get a driverless autonomous car, and that is what is level 5. So Dubai is always ahead. They have flying people, they have flying vehicle, and they also have an autonomous vehicle. We need to move towards this slowly and steadily. But for special buses and or for a special route, level 4 and level 5 can be used. And if we are going to shift to level 5, then the geometry inside the car, internal furniture is going to totally change. The seats won't be one behind the other. The seats would be in a circular mode where 4 or 5 people can sit in that circular. 7. I have been told to finish it by 9. So I would take another 20 minutes to complete this presentation. So you would see that worldwide there is a need to become sustainable through the Kyoto Protocol. And for that, we need to take care of our environment. We need to ensure that the climate change is limited, the pollutant emissions are very low, and there is no global warming because when COHC NOx and particulate emissions are emitted, also CO2 emissions are emitted, which can lead to global warming. So there is to be a limit on carbon dioxide emission, and there is to be a limit on COHC NOx and particulate matter. And the particulate matter with BS6 includes particulate matter for gasoline as well as diesel engine. Okay. And the society, I talk to you, the traffic is increasing, more and more people are shifting to cities, and population as a human and vehicle population is increasing. Similarly, oil prices are going up. There are international politics. All these things leads to shift towards electric vehicle. And for that, government has come out with special policies like emission norms have become stricter. We have skipped from BS4 to directly BS6 by skipping BS5. We have now limit for CO2 emission. we have now policies for scrappage of vehicle, and we are adopting more and more of European and Geneva policies. Our government has been very, very proactive in terms of release of electric vehicle, and from their FAME 1, FAME 2 has been introduced eventually to support electric mobility. So we need to ensure that CO2 emission, which is electric power generation and transportation, is the highest mode through which CO2 emission are generated, and hence we need to shift towards zero emission vehicle. And one of the method of making zero emission vehicle is electric vehicle. You will be surprised to know that we produce around 25 million vehicles every year, out of which 21 million vehicles are two-wheeler itself. And this 25 million vehicles are added every year. Some of them are exported. And today we have around 250 million vehicles, but it's going to move very fast. The number of roads are increasing, the highways are becoming better. At the same time, number of vehicles are also increasing. So it is compensating. So what has ARI, what has Indian government has done? So Indian government came out with National Electric Mission Mobility Mission Plan in 2020, and FAME scheme has been advocated through Niti Aayog, the think tank of India. Energy Efficiency Service Limited has floated tenders for four-wheeler electric vehicles and procured more than 10,000 vehicles through Tata Motors, Mahindra. First generation public EV charger standards have been set, and now a lot of charging stations are being deployed in various cities and also on highways. And a series of EV and shared mobility manufacturers have mushroomed, and there are at least 25 two-wheeler manufacturers and many electric car manufacturers and three-wheeler manufacturers have come up. So FAME scheme focus on four areas: technology development. So a lot of funding is done on electric vehicle development, demand creation, pilot projects, and charging infrastructure. So government is spending a lot of money on charging infrastructure, and you can read all these things in National Electric Mobility Mission Plan 2020. You can just download them from Google. The another important document which you can download is India Leaps Ahead Transformation Mobility Solution for All, which is published by Niti Aayog. It's a report for approach to mobility transportation. It says that by 2030 there will be a penetration of 30% electric vehicle in India. So today the penetration of electric vehicle in India is just 1%. And we are expecting in the next 10 years it would become 30%. That is what is our dream. That is what is our wish through Niti Aayog. So FAME India scheme has been published, and initially it was FAME 1. There were some loopholes which we modified and released it as FAME 2. And you can see that big mobility. That's so nice of government to support this. So as for FAME 2, one can get a discount from 20,000 rupees to 50 lakhs rupees if you buy an electric vehicle, whether it's a two-wheeler or an electric bus. And now about the history worldwide. Worldwide, there has been a good penetration of electric vehicle, whereas in India in 2018-19, the penetration was only 0.1%. Today, we have not even reached in 2020 or 2021, we have not even reached 1%, but we are striving to reach 30% by 2030. Today, Norway is the biggest, is the only country which has a penetration of more than 55%. I think by now it will be 60%. And the top three in terms of EV sales are China, USA, and Norway. Yes, there are other countries also like Ireland, Sweden, Netherlands, Finland, China, who has worked very hard to promote electric mobility in those countries. India is much far away, but the dreams of India are very high. So in 2018-19, we produced around 7.5 million vehicles, and in 17-18, we produced around 6 million vehicles. And this number of vehicles are increasing, but still it is less than 1% of 25 million vehicles which we produce. So it is said that by 2030, the penetration of electric vehicle would be around 30%. But there are various predictions. For example, Goldman Sachs talks about only 8% penetration and not 30%, whereas by 2040 it would be 38%. and maybe it may reach to 60%. So between 8% to 30%, there are many people who have predicted, but the roadmap for electric vehicle is laid down, and I'm sure electric vehicles would continue coming. Only at what pace and with what quantity is to be seen. Just telling you the basics of electric vehicle. We have different types of electric vehicle, whether it's a battery electric vehicle, fully battery, no engine, or in hybrid electric vehicle, which will have a battery, which will have a motor as well as engine, or a plug-in hybrid vehicle where it will have motor, engine, and also it can be charged, or it can be a fuel cell electric vehicle where the fuel cell generates electricity, and you can use a particular type of fuel like methanol or hydrogen to generate electricity. Today we are talking about well-to-wheel carbon dioxide emission. That means it's not only that electric vehicles are zero emission. Wherever electricity is produced, somewhere there pollution is created. So can we shift towards sustainable electric generation? So we can use solar energy, wind energy, hydel energy. Airports like Cochin Airport is 100% running on solar energy, and like that, there has been a lot of work done on solar powered electric vehicles. So basically, in an electric vehicle, we have a battery and which converts into DC to AC inverter. Then there is a controller which controls the entire system. There is an electric motor, a gearbox, and that's how the entire electric vehicle would run without an engine. So electric vehicles has a traction battery pack, a traction motor, inverter, and a battery management system. So basically, any electric vehicle will have four major important parts or the major pillars. The first one is the motor or the electric machine. The second one is the battery. The third one is the battery management system or an energy management system, or to ensure that charging is properly done, to ensure that there is no overcharge, undercharge, to ensure that there is no fire. We require a strong battery management system. And then the fourth one is all peripherals, that is power electronics and control. So these are the four key components of electric vehicle, and slowly we are moving towards hybridization from a small micro hybrid stop and go at the signal, and then slowly shifting towards integrated motor assist electric vehicle, pure electric, and then hybrid vehicle. Electric vehicle, we need to be very sure about the specific energy, specific power, energy density, and the power density of the battery. And also battery needs to be cooled through air convection or liquid immersion cooling or liquid cooling through channels. So like radiator, there could be a small radiator which can help to cool the battery and the motor, and there could be around the battery, there could be water circulated, like water is circulated around the cylinder block and cylinder head in the water jackets. State of charge, depth of discharge, all these are very important. And the rating of the battery, whether it is 1C, 2C, 3C. If it is 1C, it will charge the battery in 1 hour. If it is 2C, it will take half an hour, and so on. Right? If it is 3C, it will quickly charge. So how quick it charge and what are the repercussions is what we need to understand. So basically, we need to thank Dr. John Goodenough, the Nobel Prize winner who invented the battery. The lead acid battery was invented in 1859, and Dr. Professor John Goodenough invented lithium-ion battery in 1980. He has a patent for that, and now he has invented a glass battery, which is 3 times better than lithium-ion battery. So if you're planning to do business in or production of lithium-ion battery, be careful. The technology may become redundant in the next couple of years because glass batteries are coming in. So there are many anxieties which I will talk about, but basically a battery consists of cells, whether it is nickel metal hydride, metal air, or lithium-ion batteries. The conventional lead batteries are disappearing, and also lead acid battery has a life of 2 to 3 years. Lithium-ion battery may have a life of 3 to 5 years. So the life also would be higher, but no doubt lithium-ion batteries are much costlier than the lead acid battery, and hence we need to reduce this cost through various research aspects and value engineering. But the most important is the scale of production. When the more and more electric vehicles will be sold, because of scale of production, the cost of the battery will automatically go down. Today, the cost of the battery is around 40% of the total cost of the vehicle, and we are planning that the vehicle manufacturer, may be allowed to sell their vehicle without battery, and next door you can rent out a battery. So you can just pay 1,000, 2,000 rupees to rent out the battery, who will take care of all your charging, maintenance, and swapping of batteries, and you then pay very less amounts to buy a car. And that's how the car manufacturer will be able to sell more vehicles, and battery guys would get a business. So there are cylindrical cells, there are pouch cells, there are prismatic cells, and all these are combined together to form a module. So battery cells are all combined together to make a battery module, and the battery modules are combined together to become a battery pack. And battery pack is like a big battery pack, like a suitcase which is kept inside the passenger vehicle, generally at the floor of the vehicle. Fine. So you can see different types of batteries and battery packs. And the battery design is an important criteria, not only its thermal management, but how many, what should be the size of the cell, what would be the capacity of the cell, how many voltage you want, how many watts you want, and whether it is there is an electricity current passing or a fluid is passing. We need to ensure 100% safeness, and hence there is a standard called AIS 048. Any standard you want to know about electric vehicle or anything related to automobile, just go to www.ariindia.com, the ARI website, and you will find all the standards. For example, if you type AIS 048 on the website, you will get the Automotive Industry Standard on testing and certification of batteries, lithium-ion batteries. So we need to work on all these challenges. How do we make it more durable? How do we increase the range? Do we increase the life? And then for that, what type of design optimization is required? What type of reliability check is required? We need to work on that. Then there are various charging stations, slow charging, fast charging, AC charging, DC charging, and we need to work on those areas also. And there are nomenclatures and standards for the charging stations. Recently, ARI has donated one charging station to PMC in its office. Okay. So there are standards for EV charger also, and there are standards for the entire electric vehicle. There are standards for motor. There are standards for battery. So these are some of the charging stations which are developed by ARI, and around it has been the technology has been transferred to 5 companies, and ARI also has made some charging stations which are being donated. Okay. Then I am. There are various smart charging solutions being worked out. Whether it's an inductive charging or whether it's a vehicle-to-vehicle energy transfer or it is regenerative braking, there are different ways by which we need to work on smart charging solution. Also, we need to work on intelligent solution. How do you charge in a limited place? Whether there is an aerial vehicle remote charge or ground vehicle remote charge, all those things we need to work on. Battery swapping, as I told you, is a new area. For example, in Ahmedabad, there are 100 electric buses running, and they are all every day. The bus will go to a particular depot where the batteries would be changed. That you need a crane to remove such a big battery from a bus and swap it with a new battery which is already charged the previous day, and the bus moves on. So the bus doesn't take more than 10 minutes to change the entire battery system. So battery swapping solution is one such solution, and we have been working on many events like Baha, Supra, where we are working on electric vehicles. So we need to create a framework for the vehicle to grid using an electric vehicles to store energy, and we need to work on grid support by used batteries. So these are another areas which we need to work on. We don't have to throw away the lithium-ion batteries. So now I will come to standardizations or norms for electric vehicle. I think somebody had asked me that in the question. And so there are off-road vehicles which are not running on road and which are running on resorts or universities or in any big companies, electric vehicles. Then they need not be certified by any test agency. Only they have to ensure that they are run within the campus and then they don't go out on the road. Similarly, we have two-wheeler, three-wheeler, four-wheeler, buses, auto rickshaws, all designed, and these are the various category of electric vehicles in India, and they are like L1, L2, two-wheeler, three-wheeler, M1, M2, N1, N2, and so on. So regarding these standards and regulation, we started working before 22 years. Till 1999, the first committee was formed to define type approval of battery operated vehicles. So earlier we used to call it as battery operated vehicle. Now we are talking about EV. So the Central Motor Vehicle Rule Technical Committee bought this battery operated vehicle on the purview of CMVR, and then Automotive Indian industry standard were developed and approved and were approved in September 2003, and it was released in April 2005 as a mandatory requirement. Okay. So what are the standards? There are standards for electric vehicles. There are standards for electric hybrid vehicles. There are standards for retrofit. So I just have 10 slides. So I request you to have patience. I hope I am audible and it is interesting. Is it interesting?
Yeah, it is
Absolutely,
interesting.
sir. Yes, yeah, yeah, it is
Thank
Yes,
you.
absolutely.
yes, yes.
And knowledgeable.
Yes,
Fine.
yes, yes.
Fine,
Yes.
fine. Thank you. So let us complete these 10 slides and then we can have a question and answer session. So there are various regulations for electric vehicles, separate regulation for hybrid vehicles, and there are separate regulations for charging stations, for retrofitment. India is the only country which allows retrofitment. That is, there are 200. So let's see what are the standards. As I told you, AIS 048 for the battery, and AIS 038, 39, and 40 are for electric vehicle. So, for example, finding out the range, finding out the capacity, and so on. And then AIS 138 is for the charging stations, slow charge, fast charge. For hybrid vehicle, it is AIS 102. For retrofitment, it is AIS 123. And there are many other miscellaneous charges. So, once again, to clarify, AIS stands for Automotive Industry Standard, which are framed by various committees, which are where the secretariat is AREI. Okay, fine. So for electric vehicle, we have to be more ensure more safety, because there could be water on the roads, which can be 1 feet high or 2 feet high. You already have seen that experience in Bombay, Chennai, those areas. So we do a water wedding test to check IP67. That means no water must enter any system, whether it is motor, electric vehicle, or BMS. We also do an EMC, electromagnetic compatibility at AREI. So to ensure that this electricity doesn't hamper other equipments. And also a crash test is done, but there are some special requirements for the crash test compared to the normal vehicle. So ARI has come up with a center of excellence on e-mobility, where all the facilities, whether it is testing, certification, research, development, skill development, everything is available. So we need to work on various research areas. We can work on various concepts. We have softwares available from NSYS, Altair, GT, Gamma Technology, who can help you to model an electric vehicle or its component, simulate them, optimize them. We can also try to make a prototype. We can make an EV retrofit kit and then get it certified under AIS 123. We can work on battery swapping. We can make a battery management system. There is one company called Device Electronics who's been working on battery management system from last few years. And then we need to work on a system integration. So these are the various areas on which you can work, and simulation solutions are available. There are a lot of software which can help you to develop strategy for electric vehicle. So we follow a V model for the product development. That means we capture the voice of the customer through QFD, and then we do an architectural design. We do design review. We do design FMEA, and then subsystem are designed from mechanical, electrical, and software point of view, and then the detailed design, drawing, optimization, and 2D, 3D images are done, and then prototypes are made, physical prototype, dynamic prototype, and then a lot of testing are done on this to validate the entire product development system. Okay. So the current market trend is working on big data, artificial intelligence, data analytics, in-vehicle networking, energy storage solution like lithium-ion battery, deliverable ultra capacitors and glass batteries. software architecture, smart charging solution, electric motors, energy management system, electric vehicle architecture. These are the areas where we need to work on and we need to get reskilled. Now I have a couple of slides on skill development. So it is said that the technology will be very disruptive in the time to come, and this disruptive technology will drive the need to bridge the gap in the workforce competency. So the skill of workforce which are there today and the skill required after 5 years may be drastically different, and hence all this, whether they are workers, technicians, labor, engineers, everyone must be ready for reskilling. So there has been a lot of survey done by ASDC, CNBC, Randstad, McKinsey, which says that the future success of the automotive industry is in the workforce and in the electric mobility. Okay. So reskilling is a very important word. We all need to reskill ourselves. It is said by 2025, that is in the next 4 years, 85% of the knowledge will become